Okay, and then the second one is going to be this very useful, insightful lesson. You're graphing logarithm functions, but first off, let me just explain something. It's going to be like the exponent graphs you were doing the other day, where the independent variable's an exponent, where you had an asymptote and all that. Just everything's going to be reversed, and you're going to see why that. First off, you're going to cross that out, and you're going to rewrite that so it actually makes more sense. The base of your exponent, you're going to write this as an exponent equation. Base of your exponent is going to be 5. What it's equal to over here is the exponent and then x. Now last week it would say like y equals 5 to the x. Now it's x equals 5 to the y. Which means when I make my xy table, y is the independent variable, so I'm going to be putting the 2, 1, 0, negative 1, negative 2 in for y. And also that means the asymptote is no longer a y, it's an x. So it's going to be like this. Instead of across, it's going to be up and down. And here you want it, so you take 5 to the second, that's 25. So negative 5 to the negative second is 1 over 25. 5, 1/5, and that would be 1. Okay, now here's the exponent, the base is 5, there's nothing added to the y, so I don't have to transform the y, and then there's no outside operation, so I don't have to translate the x. I can just go ahead and graph this. Okay, so 25, 2, well we better go by 5s that way. So 5, 10, 15, 20, 25, up 2. Now, after the first point's graph, plot your asymptote 0. Which is easy enough. 0, and x equals 0 asymptote is actually the y-axis. I know that sounds weird, but the reason that's 0 is because anything on this line has an x-coordinate of 0 because it's right in the middle. So that's why that's it. If you want to trace over it, you can, or you can just use that as the asymptote. Okay, so 1, 5, go forward 5, 1, my bad, forward 5, up 1. Then 1, 2. So you go forward just a teeny bit and then just right there. Once those 3 points are down, you pretty much know you're going to extend outward that way as you get up here. And then you're going to get closer and closer to the asymptote that way, but you're never going to touch it or cross it. Okay, I do want you to do in domain and range. This time, all is the range, okay? Because if you look at it like that and invert it, you got arrows on both ends. But now it's the domain I deal with, x, 0, and now everything's to the right, because x is left and right, everything's to the right, so it'd be greater than 0. The whole graph has to have x coordinates greater than 0, not equal to. Okay, next one, rewrite it. The base of your exponent's 1/4, okay? What it's equal to is the y, and then the x is by itself. What a logarithm's equal to is going to be this to the power of this, okay? 1/4 to the y power equals x. Same right, when I see it right away, I know it's going to be 5 to the y, x equals 5 to the y power. Okay. So again, now the independent variable is y, so that's where I put the 2 through negative 2. And you can keep going. You can go 3, 4, 5, whatever. Okay. Okay, so 1/4 to the second, you can do that. 1 to the second's 1, 4 to the second's 16. So that would be 1 over, so this would be 16. 1/4 to the first is 1/4, that'd be 4, and to the 0 power is 1, okay? Once again, this is my exponent, there's nothing being added, so I don't transform the y, and there's no outside operations with the 1/4, okay? So this is what I graph. And the asymptote, now, instead of x equals 0, or instead of y equals 0, it's x equals 0. Okay, so we're going to graph down here 16, 2. We'll go by 2s there. 2, 4, 6, 8, 10, 12, 14, 16, up 2. Or down 2, my bad. Get rid of that. It was negative 2. 4, -1, so 2, 4, -1. And remember, the asymptote now is a vertical. It's not horizontal like it was before. Okay, 1, 0. Remember, you're going by 2s, so 1, 0 is right there. Okay, so again, you extend out that way, and then the other way, we will never cross this right there. And that's the graph of that function. So the domain, now the range, okay. See, to get it to look like I did before, I would reflect the graph like that, okay. And there's arrows on both ends, but since I'm looking at it like this, it's going to be the range that is all. And the x, and all points are to the right, so that would be greater than 0. But you not equal to, because you never actually cross the 0. Okay, next one. So you kind of write it in reverse. You're going to have x by itself and then base 4 to the power of y. You kind of have to just memorize how that's written, okay, to be honest with you. All right, so this time it's the y, 2, 1, 0, -1, -2. 4 to the second would be, x would be, if y is 2, 4 to the second, x would be 16. If y is 1, 4 to the first would be 4. So this would be 1/16, that would be 1/4, and that's 1. All right, and then you have your asymptote, but this time it's the x that can never be, that will approach 0. So 0 there. And again, you don't have to transform the graph, you just go with what you have. You don't have any operations to the exponent, you don't have any operations to the base 4. Okay, so again, 16, 2. So 2, 4, 6, 8, 10, 12, 14, 16, up 2, and then the asymptote's right there. It's going to go like this or like this, whatever direction it takes me. 4, 1, so 2, 4 up 1, 1, 0 right there, and you can kind of see how that's going to roll. Here you just slide against the asymptote. Domain and range, this time the range is all, but the domain is going to be x, and everything's to the right of that line right there, so 0 greater than. Okay, now remember a rule, if you don't have a base, it's automatically 10. Okay, so it's y equals log base 10 of x. Okay, so I basically just reverse the order. X comes over here, then the base is 10 to the y power. You see, you're kind of just going backwards with it. X, base 10, y power. Just trying to help you remember that a little bit. 2, 1, 0, -1, -2, 10 to 2, oops, again it's, oh, shoot, I knew I'd do that. 2, 1, 0, -1, -2. 10 to the second is 100, so the negative second's 1 over 100, just a really small decimal, 100th. 10 to the first is 10, that'd be 1/10, and that's 1. Okay, so 102, I'm going to go by 20s, okay, and again the asymptote is now a vertical asymptote where the x is 0. So no matter what you do to the y, you can't ever get 0 or beyond 0 for the x, it's impossible. That's what an asymptote is. Okay, so 20, 40, 60, 80, 100, up 2. You can have this be 20s, this be 1s, it's all good. And then that 0 is now our asymptote's vertical. 10, 1, so that'd be halfway, up 1. 1, 0 is just forward a teeny bit, and right there. Okay, and the same thing basically happens. Okay, there's a graph. Okay, so the asymptote, or the domain and range, you got x for your domain, y for your range. Okay, so if I wanted to do the domain and range like I was doing last time, I'd have to invert the graph. And you see arrows on both sides, but now it would be the range that's all. And then it'd be the x, that would be the 0, and everything is to the right of that, so it's greater than or equal to.